Hi guys, so for this video we're going to talk about how we're going to do 2D CNC milling. So when you have a job that you want to do and it's maybe too thick for a laser to do, you want to do it in more like a plywood kind of thing, then a CNC is what you need to do that job. And most often we run the jobs on the 2D. We don't really need more access than that. So a small example that I have here today is that I made this small dressing shirt rack here, and in the bottom I made this plate. There has this particular pattern in it, and of course this is a perfect example for a job that you would run on a CNC mill. It would just take forever to do it by hand, but it's an easy job for CNC. So what we're going to do here first of all is that we're going to have to go into the manufacturing workspace. So this is a video about how to do the milling and not how to do the actual design, so we're not going to go into that. Okay, so here we are in the manufacturing workspace. The first thing that I'm going to do is I'm going to hide some of all this stuff. So I actually both have a top shelf and a bottom shelf here. So first thing that I'm going to do is I'm going to hide all these pipes. So if I press on one of them and I type V, that's going to hide the bodies and components. So I have a few bodies here. And I'm also going to hide these feet. And then I also have some small spacers in here that I'm going to hide away. And for now we're also going to hide all the things here in the top. I'm just going to highlight those, type V. So now the only thing that I have in my workspace is this one sheet here. And this is what I'm going to go for the CNC mill to do. Okay, so what we're going to do here is we have to set up the job. The first thing that I recommend you to do is that we have to figure out how the setup is going to work. So the first thing we need to do is click Setup. And that is going to start out highlighting your model. And because we hide everything, it's going to only select this one part as being the selection and the work area, shown by the stock around it here. If yours is bigger, then it might be because of your model is not selected correctly. So if I just unselect this, you might see that it's trying to stock in the whole cabinet or the whole rack. So what I'm then going to do is I'm just going to click on this model here, and I'm going to click on the model that I want to work on. So like this. The next thing I want to do is I want to take care of this work coordinate system, and that's where the start point for the CNC mill is going to be and how the orientation is supposed to be. So that's going to be specific to each machine where I work, and we have a CNC mill, and we put it on our website how the X, Y, and Z is going to be. So if I go to Fab Lab, like this, under here we have the tabs for machines, and all the way here in the bottom we have something called the CNC Milling Large. This is the machine that we're going to operate. So we put in the picture here that this is being the X direction, and this is being the Y, and upwards being Z direction. And we usually put the start point here in the end, so that's also where how I want my start point on inside of Fusion to be. Another thing while you are here that you also might want to do is down here for Fusion 360, there is that you should use the tools that we have available. So you can download our tool library here. So if you press this button, it will direct you over to Google Drive, and you should be able to download it up here in the corner, and that should give you a file that you could save it for. Okay. So how do we correct this work coordinate system? What we start by doing is that we can do this orientation, model orientation, or we can press this one and we can either choose a Z-axis and an X-axis, or a Z and a Y-axis, or some other stuff here. So what I'm going to do is I'm going to choose the Z and the Y direction. So what I can do then is so it starts by highlighting the Z-axis here. And that is already going upwards, just as I want it actually. So I don't have necessarily to actually give that a direction, but what I can do is I can select either a face that is normal to or perpendicular to the Z-axis. So I can press this top face here, that's going to give me the way. I can also press this axis right here. An axis there is parallel to the axis, and I can even use my models. So in here we have an axis. There is also going to be parallel to the z-axis. So it might be flipped like here because I chose an axis and it's just going to flip it. It's not a big deal. I can press either on this arrow right here and that is going to flip it, or I can press over here on the flip z-axis. So the next thing I'm going to do is I want it actually is to be the y-axis. I'm just going to select that one. So how I want this to be orientated is that I want the start point to be up here, and I want it to have x in this direction and y in this direction. So I'm just going to press y-axis, and I'm going to press this one here, and that should flip it so that my y is now parallel to that axis. But again, if we go in here into the place, I want the y-axis to be pointing in this direction, so I have to flip it. So again, I'm just going to press on this arrow, and now you see that I have y, x, and z in all these configurations. And now I just want to put the start point here up in the corner. And how I'm going to do that is I'm just going to press this one stock point, and that's going to give me different points on the stock here. So I get some points, so I can press, for example, this one, and I want to make sure that it's on the top one up here, because when I'm going to go in with my CNC mill, I'm going to touch off on the top face, and that's going to be our stop point. So the next thing that I want to do is I just want to take care that there is no additional stock. So underneath this tab right here called stock, there is this thing here, offset mode. And I can put this to no additional stock. First of all, I'm just going to show you what it is. So if I just choose to go to a face there is directly on the side, you can see here that it puts a little bit of stock on the top side, and I don't really want that. The same thing goes for the sides, that it puts additional stock on the out here. That's usually what we need to do for metal work, especially because we want to face off sides or something. We don't really need to do that in wood as much, so I just recommend you to do no additional stock mode. So that's just going to put this is the dimensions that you need to cut. So I'll need to have this piece. I can see here that it is 1,200 millimeters in this direction here, and it's a 12 millimeter thick plate, and it's going to take up 540 millimeters in this direction. So that's all I'm going to do here. I'm just going to press OK. So now I have the setup done. Now I have to create the tool path that is going to tell the machine how to operate. So this pattern right here has a lot of these internal holes, and I don't want to select every single one of them. I just want to make sure that it actually does cut the inside of all of this before it cuts the outside. It's very important that it doesn't cut out the outside first. So the way I'm going to do that is we have a lot of different toolpaths to use from, but you can use the contour mode under 3D here. So if I tap this button here, I get my menu, and then I have to start out selecting a tool that I gotta use. This is where it's important that you had downloaded the tool library that we had. So right here I have what's called the Raptor machine. This is the tool library that you just downloaded, and in here we have different tool selections. When you want to import a tool library, you have to right click on local and then press import, and then you just have to tell it where the location is. So for me it was under downloads, and here is my tool, a Raptor tool library. I'm not going to open it because I already have it. So Raptor, and the tools that is most often in the machine that we use most of the time is this 3mm here. With the new tool library here, we also added in cutting data, so you can actually select softwood right off the bat here, and that's going to have a lot of the different parameters built into the tool, so you don't have to do as much fiddling around. So I'm just going to select that, and in a minute I'm going to show you if you don't have, I'm just going to do it now actually. So if you don't have the tool library looking like that, you could go up here under your name and then go under preferences, and down here in the bottom there is this preview features, and under manufacturing right here there is this thing called tool library. Right now it's a preview feature. I recommend you to turn it on just because it will improve how your selection is going to be, but in short future this is not going to be here anymore because it's going to be default inside of Fusion. Okay, so contour, that's all what we already did. Selection tool, Raptor machine, and this 3mm and softwood. You can also do the presets right here, so you can choose either the default preset or the softwood. So it is programmed so that if you do the softwood, it's going to have the correct feed rate. So the important features that you have right here is that we are spinning our spindle at 24,000 RPMs, and the cutting feed rate we're using is 1600 millimeters a minute. That's because the step over, so we're going to see what is called a step over, is how deep the tool is cutting at each pass. That's you have to figure out the correct feed rate compared to how deep you're able to cut. Okay, so the next tab up here is called geometry, and what you have to do here is we have to select where the tool should cut inside. So if I choose this outer perimeter right here, it's going to default to selection and have a chain machine boundary. So what I'm telling the machine right here is that you can only work inside this area right here. So you're not allowed to work outside of that, and because it's not allowed to go outside of that, it also is not going to cut out the outside perimeter of all of this. So the next thing I want to do is I want to go under tabs, this tab up here called heights, and on the bottom height I just recommend you, when you have a through cut like this, that you put it to -1 millimeter, and that's just making sure that in case that the material is maybe 12.2 millimeters thick, or the whole bed of the machine isn't level, that we actually cut an additional millimeter below just to make sure that we get a cut that is going all the way through. So the next thing here is heights. We're not going to do anything in here because we already have the tool library done, but the important parameter in here is that there is a maximum step over height that's called at 8 millimeters. We might come back and change this, but I will show you in a minute what it's for. The next thing is called linking. What I recommend you to do here is to turn off lead in and lead out and put the ramp style to plunge. So if I hover over this, you can see some of the different things, where plunge being second one here, where we just go straight into the material, where a helix is the one on the bottom right, where it's like going in a spiral, going into the material really slowly, which you need to do for good chip evacuation in metal, but it's not necessary for soft materials like wood. So plunge is just what I recommend you people to do. And then I'm going to do OK. So this is going to generate a toolpath, and it can take a minute for it to process, just because it's going to calculate everything in here and figure out how to run it, and then it's going to give you a preview of how the tool is going to move. So there we go. All the blue lines is where the bottom of the tool is going to be. So right now I have these blue lines in here, and each line represents how deep it's going to cut. So it's going to cut in 3 passes, all of these. So it's going to go around on this blue line, and then the other blue line, and the last blue line here in the bottom. And then we have all the yellow connections. That's where it's going to go up and over and into a new hole. So I actually want a 12 millimeter plywood sheet to be cut in 2 cuts. So I want it to go down 6 millimeters, or maybe 7 actually, 7 millimeters down, and then do 6.5. It's going to do a 12 millimeter cut, so half of that will be 6, but I added another millimeter in the bottom. So if I put this to 6.5, it's going to go halfway through, and then it's going to do the additional half. So I'm just going to correct that by right-clicking on contours and clicking edit. And then here on the passes, I should put this to 6.5 millimeters. And I also need to turn off this flat area detection. If I leave it on, you can see that it's going to have still going to have these 3 levels in here. Just a second. So you see it still has 3 different levels. And I don't really know why. I just figured out if I turn it off, it's going to remove it. So if someone finds out why, please tell me in the comments below. So now you can see it's doing it in 2 steps. That's how I want it. It's going to go 6.5 millimeter down and do the rest of the cut. Okay, so now I have everything cut out. I just want to make sure that it also is going to go into these holes I have here, and making sure that it's also going to do those 2 steps. It is, so that is perfect. So right now we have cut everything inside. Now we need to cut the outside. So for cutting out the outside, I recommend you to use what is called a 2D contour instead. You can also click here and find it as a 2D contour. The difference between the 3D toolpaths over here is that you have to tell Fusion where to work inside, and with 2D you have to tell it exactly where to cut. So if I'm going to choose 2D contours, it already pre-selected the tool that I used before, so that's good. I want to use the same tool. Under presets, I'm going to use softwood again. I'm going to go under geometry, and here you have to select a contour. And it's very important now that you select the bottom of your contours that you want to cut out. And the reason for this is under the next tab. In here on the bottom height, it's selected bottom height as selected contours. So that's why I selected the bottom one. And this one is going to be -1 millimeter again, just to make sure that I cut all the way through. And passes. Now the thing that we before called step down is called multiple depths. It's the same thing. So I'm just going to put this again to 6.5 millimeters and have the rest of the settings looking like this. Linking should already be like it doesn't have the helix style. And again, I might be tempted to turn off lead-ins and lead-outs and pressing OK. So you see again, I get these 2 lines going around, showing me how it's going to do. And now the amazing part about Fusion is that I can simulate how all of this is going to cut in real life. So if I go under this one up here and first of all I click on setup, that means that I want to simulate everything there is inside the setup. I press the simulate button. I can press stock, so that's going to put a box around so I can actually see where it's going to cut. And then I can press play. So now you can see in here how it is going to cut out the different parts. You can see that it cuts out first and then it goes deeper, and it cuts out the second and it goes up and over and cuts the next part. So if you want to speed the process up, you have the speed control right here. So this is the speed control. I can speed it up so it's going really fast. I can slow it down so it's going rather slow. And down here in the bottom, I have what's called the timeline. So that's showing me where the tool is right now. And you can see right here that this tool here is going to stop this command right here, and then it's going to do the other command. So just like this one up here, this determines the order. So it's going to start doing this one, and it's going to then jump to the next one and finish that part out. So if I, for example, close this and I just drag the 2D contour above the outside contour and I simulate this once again, you can see how it's going to start out cutting out the outside perimeter, and then after that going to do the inside. And that's not what we want, because cutting out the outside like this will make sure that the sheet in here is loose and it will wriggle around, so it's not going to be precise anymore. So we don't want it to do that. So it's just a good way of error detection if there is something. you can also see it's also going to tell you if you are doing a too deep pocket. Of course, if our tool has the stick out here, so this is the amount of stick out there is on the tool. Usually, it's of course going to be how people are adding in the tool, but most often this is the amount of stick out that we have that people put in as default. Like there can still be errors, but Fusion is also gonna give you an error if you are crashing the tool into the material, like if you're sticking in so deep that the tool head up here is going to crash into the material. It's going to give you errors like that. So this is just a simple way of doing the 2D contour here. Okay, so now if I wanted to do the top one as well, because I also had the top shelf, I can right click on this one and show all bodies and show all components. That's going to give me all my things back. And I also want to cut out this part up here, but this one is just a 2D contour around the whole place here. So what I can do then is I can, for example, duplicate this setup right here. So if I click duplicate, it's going to give me a new setup down here. First thing I'm going to do is I'm going to activate it, open it, and I still have these two contours. First thing is the setup. I can right click on setup. I choose a new model. So if I click that and I click this one up here, you can see that it automatically did all of that and put the start point at the right place and the Y and X axis, and again, no additional stock. So I can just press OK. It's going to give me errors because it cannot figure out how to do these cuts up here because I haven't selected the correct contours. We just talked about that we only need the 2D contour moving around the outside, so I can just click on the 3D contour and press backspace or delete. And then I have this one. If I right click and I press edit and I do geometry, you can see if I zoom out that it still has this down here selected because I of course duplicated it. So just going to click on the X. Then here, clicking on the bottom again, pressing OK. It's going to generate the toolpath and clicking setup. Oops. And then clicking simulate. I can see that it does the exact same. It does the same thing here, so it works. Okay, good. Last thing you need to do when you are going to run a job is that you of course need to export the code that is actually going to be run by the machine. So what we're going to do there is we're going to click on the setup and we're going to right click, then click post process, and then over here under post processor we're going to have to choose this one Mark III Mill. So if I click on this one and I just press M. If I was under another one, I can just click M, and then I'll get to this place, and I press this one. The default is often that this one is checked. I want just uncheck it, because we don't have to see the actual code and do any modifications to it. Then I press OK, and that's going to give me that a place you want to save it. So I can just save it. I can give it a new name here, and I'm just going to save it on the desktop. If I want to export the other one, I can right click on this one as well and click post process. I can maybe call it 1002, and you can see if I press OK, it's just going to default to that name again and save it. And now I have the two G-code files that is going to be loaded into the machine. We're going to do a tutorial on how to import G-code into Mark III Mill in another video. That's all I had for you guys today. See you later.